In this class we want to talk about the systems approach to management theory. Now, the classical system concentrated on organizational form and ignored the needs of the people within the organization. So the classical system was to do with the design, with the layout of the organizational form. But generally speaking, we skipped over, or if you look at the video on the classical system, it skips over people to a large extent. The Human Relations School, which is a second school of management theory, it concentrates on the needs of people and largely ignores the organizational form. Well, the name, the Human Relations School, is a giveaway. It suggests that people are central to its consideration and the organizational form are not. So we have two approaches here on the slide. The first one, the classical system, which emphasizes structure and form, ignores the people. And the second one, Human Relations School, emphasizes people, emphasizes the workers, the managements, their needs, their requirements, and so on, but tends to ignore the organizational structure. The systems approach, you've probably guessed, falls somewhere in between. It was developed in the 50s and into the 60s. It sees the organization as a system and composed of a number of subsystems. So we have to see the company or the organization or the factory, whatever. We have to see the organization as a system, and within that system there are subsystems. It also sees the organization as capable of responding to a changing environment. So it's an organization which is a system, but it's a system that is able to change itself according to the requirements from the environment. So let's deal with the systems approach. Now, a system is a set of interdependent parts that work together to carry out some function. A system is a set of interdependent parts that work together to carry out some function. Simple. Interdependent parts working together to carry out some function. So the definition is very, very straightforward. We can relate to that. That is what a system is. A good example of a system is the human body. And it also has subsystems. There is the circulatory system. There is the nervous system, the digestive system, and so on. So within the human body there are subsystems. They're all working to do separate jobs. The subsystems are connected and also linked to the overall well-being of the system, the human body. So they're all linked, presumably through the brain, but they must function and do their individual jobs for the overall system, the human body, to feel well. Now, this analogy with the human body we can take into organizational studies. Katz and Kahn, 1966, they identified 5 subsystems in an organization. So let's have a look at these 5 subsystems. First of all, there's a technical or a production subsystem. Well, if it's a manufacturing business, that's certainly the case. It depends crucially on the nature of the business, but even an office business will have some sort of process. It'll be processing perhaps information, and the information will be flowing from perhaps one operative or one worker to the next. So there was a sort of a subsystem there in play, similar to manufacturing. And there are subsystems, and there must be support for the subsystems. So the subsystems have got their own little, they are their own little systems as well. They have got people maintaining the subsystem. So within a company you might have IT staff looking after the computers. You may have maintenance staff looking after the building. They're doing different jobs. They're still looking after the subsystems, and they're offering support to the subsystems. And the maintenance of the subsystem is to maintain the overall system, because if a subsystem breaks, then the whole system can break. So now we're starting to see an organization as built up. It's a system, but it's built up from subsystems, maintenance, IT section. It'll have inputs from designers and people with specialist skills. So all of these will be out to maintain their own subsystem, and their own subsystem leads to the overall well-being of the system. I know it sounds complicated, but really it's very simple. Each of the subsystems must work. If they don't work effectively, the overall system will have a problem. And the subsystems must be adaptive. The subsystems can't be fixed rigidly for all time. They are learning subsystems. They must look at the environment and find out new technologies, new way of doing things, new processes, new way of thinking, and so on and so on. So the subsystems are constantly monitoring themselves. Not only is the system monitoring itself, but the subsystems are monitoring themselves to see if they're doing it the best way, if they are if they're adding value most effectively to the overall system. And the subsystems need management. They need to be not just supported and maintained and allowed to adapt, but they must be managed. So the subsystem is where the manager fits, looking after each of the subsystems. So within a production system, you might have a subsystem which looks at making a certain component, just making the one component, but it's an important component, and that becomes a subsystem. It has its own requirements, its own machinery, its own specialists, and perhaps its own manager. The product it makes is only of value because it adds to the overall product made by the full system, by the full organization, which is the product which will be sold at the end. But that subsystem is important, and it needs management. So they are connected. All of the subsystems are connected. The production subsystem will depend on the stores subsystem, supplying it with raw materials or semi-finished products. The stores will be looking at new ways of trying to store the products efficiently and predicting demand using perhaps computer simulation or whatever. So there'll be technical subsystems, support for the subsystems, there'll be maintenance of the subsystems, trying to maintain that particular aspect of production. The subsystems will be adaptive, they're trying to learn, trying to make themselves better. They're being managed, they're not just left to their own devices, they have proper management, and they are connected. So the systems approach, well, the systems approach is concerned with the relationship between people and technology in the workplace. So it's concerned with the relationship between people and technology in the workplace. This particular view was put forward by Trist and Bamforth in 1951. Introduced the concept of a social technical system or a socio-technical system. New technology caused disputes and low morale amongst the workforce. Workers don't like change. they have resistance to change. So they need to be involved in change. It needs to be managed. And when they have that sort of resistance, it must be recognized that people are important, the workers are important, but so also is the technology. So some sort of compromise must be struck. They viewed that the working environment was an interaction between the social needs of the workers and the technical requirements of production. So production needs to be efficient, it needs to be up to date, it needs to have the best equipment, it needs to be managed and dealt with in the most efficient manner. But the workers don't want to retrain, or don't want to perhaps be constantly under pressure to learn new skills or to adapt. So there's always resistance to change, and there is a tension in the workforce between these two components. The systems approach takes a wide view of the organisation and tries to build in people and the needs of the workers into their view of the overall system. Now, let's look at another area which is related here, and this is scientific management, put forward by Taylor. And this will illustrate how, if you like, subsystems can be broken down into very, very small levels, and how it was viewed that they could then improve efficiency by strict monitoring and measurement and feedback and so on. So let's have a look at this idea of scientific management. Taylor formalized the principles of scientific management, and the fact-finding approach was a replacement for the rule of thumb. Now, there are two approaches really. One is to set up the production system and let it run and keep your fingers crossed that it's going to be okay and it's going to be effective. The other one is to measure and calculate and be precise about what is required from that particular subsystem. Well, Taylor introduced this idea of scientific management, which was this very formalized measurement and monitoring approach. And this replaced the crossing your fingers and hope that everything was okay approach. So let's have a look at Taylor's approach to scientific management. First of all, he started in 1895 with work on incentive schemes to try and get workers to work harder, and how could that be done. A piece rate system on production management and the shop floor management. So instead of paying workers, let's say for 40 hours a week or whatever the working week was at that time, instead of paying them for that, pay them for each unit they produced. Now, this would give workers incentive to work hard. The more they produced, the more they got. So a piece rate system was devised as a way of getting workers to work harder. After all, if you pay people for, let's say, 40 hours a week, they could be there for 40 hours a week but not doing very much. This particular approach was pay them per unit produced. In 1909 he published the book for which he is best known, The Principles of Scientific Management. A feature of Taylor's work was stopwatch timing as a basis for observation. It became known as time and motion study and work study and so on. So, and it's still around. We still measure how long it takes to do certain jobs. So Taylor was keen to try and work out what is efficiency, how long should it take to do a particular process, and in that way overall costings and overall timings could be worked out for the completed product. Now, the objectives of scientific management, well, firstly, it was the development of a science to replace the rule of thumb method. The rule of thumb meant set it up and hoped it was okay. Just see if it works. If it works, that's okay. Try to get it going as fast as possible and hope that'll be okay as well. It was a very hit and miss affair. The development of a science, a precision with measurements and timings, that's the difference. Secondly, workers had to be properly selected. They had to have an aptitude for the particular job. It wasn't just a question of getting a worker off the street. It meant getting the right worker off the street. People who wanted to work in a particular area, with a particular set of skills, or wanted to develop that. And training must be given to those people as well, to ensure that not only the right people are recruited, but also they're given the training to maximize their performance on the job. This is a whole development need, and put an extra dimension onto the supportive agencies within the organisation. Not only had the organisation to look out for the human welfare, health and safety and that sort of thing, but also to provide training, on-the-job training, so the workers could maximize their performance. There should be cooperation between workers and management to ensure that the work will be carried out in accordance with scientifically devised procedures. There's always a tension there between management and workers. Management will perhaps do timings and say a certain task takes a minute to complete. Well, it's in the interest of the worker, when the worker is being timed, is to go as slow as possible. So the minute will be a minute and a half as far as the worker is concerned. And then it's up to the management to say, no, you were not fair when we did the timings, you were working slowly, you should work faster and you could do it in a minute. Now there's the basis for a dispute here, a dispute between the worker and the management about the timings. There's no way around that one. That's human nature. If the worker was allowed a minute and a half, it would mean that the worker has gained a 50% in that case increase in benefits, perhaps in salary, because the worker could produce it in a minute, but they have been allowed a minute and a half. So the basis for a dispute certainly sits in there. So there is an issue between workers and management, and they have to have some agreement. They have to settle down and say, to be fair, it can be done in this time, and so on. That's it. And there must also be a recognition that the management is pulling their weight. The management is helping the workers. The management is facilitating the throughput. It's not just a question of setting up the timings and being very scientific and measuring the whole work process, and then for management to walk off and take it easy. The management should be there, involved with the workers, trying to help them to achieve their target. So that's the objectives. Now, let's look at Tailors' contribution to organizational theory. Well, his framework for the organization was a clear delineation of authority. It should be clearly understood who's in charge. And the workers should be taking their instructions from one person, just one person above them. But there should be a clear line of authority, so everyone knows exactly where the line of authority is. there should be responsibility, and the responsibility should be obvious to everybody working in that section. The workers have a responsibility for the machinery, for health and safety, not being silly at work, not taking chances or risks, to stop when it's dangerous. There is a responsibility on the management to ensure that the workers have the best conditions to work in, that the atmosphere is clean to breathe, and good lighting, and temperature is correct, and so there's an onus on the management, a responsibility on the management to ensure that the working environment is good and that the workers have every chance to meet their targets. There's a separation of planning from operations. There are two different functions. So the operations, the manager in the operations section is involved in doing what is required now, whereas there may be another layer of management which is trying to plan ahead, to look at a better way of doing it in the future. New production system, a new factory, a new way of getting raw materials, a new process. There should be incentive schemes for workers. Workers should feel that the more they work, the more they get. Simply paying a sum of money for time spent on the premises was not efficient. The management should only be worried about things that go wrong, not the things that go right. So it's when something happens out of the ordinary, that's what brings management into play. On a day-to-day basis, when everything is working smoothly, the management should stay out of it, should not impede the work process, should not hold up workers, should not stop the production system, because everything is working. Leave it alone. But when something goes wrong, that's when management get involved to get it fixed as quickly as possible and get the system back online, get it working. There is a task specialization as well, and that also runs right across the whole organization. Specialisms are all the way from the CEO, who's got special characteristics, through specialist departments. Accountants have got particular qualities, and statisticians, computer experts, and marketing people, and personnel, and so on. They've all got their own particular specialisms, but it goes all the way down to the shop floor, down to somebody performing a particular task. They have done the same task many, many times. They have an expertise in doing it. And scientific management recognizes that this sort of task specialization permeates, it runs right through the whole organization. So we'll look at some of the particular problems with this view. Well, managers could influence the rates paid to workers. Sometimes managers who are human might be out to grind an axe, or out to bully somebody, or out to upset somebody, maybe get rid of them because they don't like them or whatever, and maybe change payment systems or timings on jobs. Or so unscrupulous, it's open to abuse by unscrupulous managers. The motivations of workers, that man was rational and would make economic choices based on the degree of monetary reward. I think the view is that within scientific management, if workers are paid a piece rate, they're paid for each one they produce, they will work hard. But they may not. Some workers might think, I will do enough, I will be happy, I will not work till I'm exhausted, I will work a moderate amount of work, and I will go home and be happy. okay, I'll have less income, but I'll be happy. So we don't have to accept this idea of maximization, the homo economicus, the rational economic person. We're not accepting that. It may be that workers have a different perspective. The strong criticism of the theory, well, some people say it treats workers like machines because the job is repetitive. The task is repetitive, perhaps. And people get bored. People are human. They've got feelings, emotions, and if they're doing the same task day in and day out, it's mindless. They don't feel valued. They're there because the flexibility of the human body enables them to perform the task more efficiently than a robot. But if a robot could be designed to do the task at reasonable costs, then I guess the human would be made redundant. But there is an issue here, treating people like machines. Humans are not machines. Humans have senses. They have feelings. And they have emotions. And doing the same task repetitively, that may not be the way to treat people. It also assumes that people just respond to money, and of course they may not. People may like praise and status, and they may like a nice working environment, chatting to their friends and getting on with their job, but at the same time talking about football or talking about things that are happening on the outside or talking about their families. They're not concentrating entirely, running at full speed to get maximize output so they can maximize their income at the end of the week or the end of the month. Perhaps workers are satisfied by other things rather than money. The assumptions underlying Taylor's work, well, there is a presence of a capitalist system, a money economy, a free market, and a maximization of profit. I suppose what you could say here is that capitalism, at least you can walk away in some cases, depending on the economy, depending on your skills, depending on your mobility, you might be able to move job. But there is this idea that we have organized society around free enterprise, a free market economy, and that is the best way to organize it. That seems to be the underlying assumption. It assumes that people will work hard and behave rationally to maximize their own income. As I said to you earlier, not necessarily the case. We're humans and we may not respond in that particular manner. There are advantages to the division of labour and the specialisation of tasks. That is true. But the division of labour leads to boredom, as I said. Extreme division of labour can be extremely boring. Even within professions, an accountant is an accountant. The accountant cannot fix the car, perhaps, or the accountant cannot climb a mountain for a living. The accountant sticks by the rules. Now, some accountants will be even more specialised, and the more specialised they are, the greater their income because they have more skill in a very specialised area. But the smaller the job is also. And that could mean it becomes a very boring job. So here, in this session, we've looked at this idea of systems and subsystems, and we've got on to look at scientific management in the second part of this particular video. Okay, so that for now concludes this video. Thank you for watching.